All right, now we just want to look at this idea of a list and some things with that. Um, a list, I can make a list. I'm going to call it L equals. And to make that list, for us, we'll just look at things like, 2, 3, 5, 7, something like that, and close that bracket. So it's a opening square bracket. I do my list and then a closing square bracket, and see it over here. It says a 4-element list. Now, if I want to look at get the value of any of those, I can simply say L, use the brackets, and then which position do I want? So I have to count 1, 2, 3, 4. So for instance, if I say L2 here, notice it comes up with the value 3 because that was the second position there. So that's how you can get at these sorts of things. So for instance, if I wanted to draw a line through the origin with slope 3, from that list I could do that. Okay, and if I wanted to use the 7 instead, I could go here and make a 4. Now, a nifty thing about Desmos is, suppose I wanted all 4 of those lines and I wanted to compare them all at once. Well, actually, if you don't tell it what to use, it will just do that thing separately with each one of those 4. So it made the 4 different lines. So this is the lowest slope, so that must be L1, or a slope of 2, then a slope of 3, then a slope of 5, then a slope of 7. Pretty nifty. Okay. And so similarly, if I just said L divided by 10, it would say I have a 4-element list. So now I didn't give that to anything. I didn't call it anything, so it'd be hard for me to see what those values are. But if I call it something, like maybe I'll call it list 1 equals. Now if I look at list 1 and the first, uppercase, list 1 and the first entry, 1, I get 0.2, which is indeed 2 divided by 10. So see, I could make a new list from the old list that way. Some other things I can do, suppose I wanted to add up those 4 numbers, right? I could say 2 plus 3 plus 5 plus 7, that's 17. Now I could do it in the list notation here, so I could say L1 plus L2, whoops, try that again, L2 plus L3. This is kind of a pain to do this, but we're going somewhere with it. 4. And you see we get 17 again. Well, actually, so what I want to do is sum up those things. So I could say sum, SU. Now, when I hit the M, it makes this whole big thing. That thing is a Greek letter sigma, and we use it in mathematics for sum. And then the N is going to be to tell me how many things to add up, and exactly what they are. Well, I was adding these 4 things, so I'm going to say 1 here, then I'm going to up arrow and say 4. So I'm going to add up 4 things, and what am I going to add? Well, L, and I'm going to use the N as the position. I want position 1, then position 2, then position 3, then position 4 to add them up. And so what this is just a short way of writing that up here. So I've made a shorthand notation of that by doing the sum. And you see, I get 17 again. These are all just adding the numbers 2, 3, 5, and 7 because those were my numbers there. Okay, and we could even, we can put these into bigger calculations, that sort of thing. Now let's try something else here. Let's make an S equal, and I'll do 4 things. I'll do a 1, a 9, 21, and a 28. And I think this works this way. Now that I think about it, I'm not real sure. But I'm going to call this D equals, and I'm going to take S, that's a 4-element list, divided by L, and it's still a 4-element list. Now, I took 1 divided by 2, so I should get a half. And then 9 divided by 3 is the second one, so I should get 3. And then 21 divided by 5, that's like 4.2. And then 28 divided by 7, which is 4. So the way I can look at that is, I can look at D1, and that was 0.5. I could look at D2, and that was 3. So see, using lists can be a very quick way to do some arithmetic if you've got the same thing to do with a bunch of different numbers. 3, there was that 4.2 I said, and D of the 4th position is the 4. Okay, so that took each number in turn, 1, 9, 21, 28, and matched it up with its same position up here and did the division of S divided by L. And so I got all those answers very quickly here. Now I still had to, look at them to find out what they were, but I have them. Okay, so that's this idea of lists, and we're going to use those in the project. In some ways they're pretty simple, but as soon as you start throwing in some notation like that, it can definitely look quite complicated. But there we go. There are lists. Whoops, wrong thing. What do I want? Finish recording.